In this session, we look at the location planning and analysis. There are many possible reasons for location decisions. For example, as part of the marketing strategy, expand the market to new areas. There has to be a good reason that makes the relocation attractive. We have to bear that in mind. Why? The location decisions are important. It is at a strategic level. Usually that means executives make such a decision. So if we look at the business strategy, low cost is one out of the 4 dimensions in terms of competitiveness. It is a long-term commitment of resources. That decision is difficult to do reverse and be capital intensive. Let's look at the techniques, analysis techniques. We will introduce 4 different kind of techniques here. Cost profit analysis, rating, center of gravity, and transportation model. First, let's look at an easy one, that is cost profit analysis. Here's the formula. We have total cost equals to fixed cost, which we write it as FC plus volume times quantity. Okay, so we see the similar formula before in our break-even analysis. Now let's look at an example. Here comes the example. There was the fixed cost and a variable cost for 4 different potential planned locations are as below. And our purpose is to find the one with the lowest cost. Location A with a fixed cost per year is $250,000. Variable cost per unit is $11. That means every time when we make 1 unit, the cost is $11. Make 1 unit or 1,000 unit or however many under the capacity, either way, the upfront we have to pay $250,000. Now for location B, the fixed cost is $100,000 per year, and the variable cost is $30 per unit. Now C, $150,000 unit variable cost is $20. D, fixed cost is $200. Variable cost per unit is $35. So we can see that for different locations we have different fixed cost and different variable cost. So here comes the question, which location is ideal? Well, think about that. Answer probably is depends. Now, what we need to do is figure out exactly in which situation, which location is the best. Graphically, we can show the cost profit structure as the following. We have x-axis here, that is the horizontal axis, the quantity, in other words, annual output. The vertical line, that is the total annual cost, total cost. So the formula, as we saw, is TC equals to FC plus V times Q. For example, for location A, we know that the fixed cost is $250,000. Variable cost per unit is $11 times Q. So total cost for location A equals to $250,000 plus 11 times Q. Basically, what we are doing here is to plug in the numbers of FC, V, the variable cost for location A. This line TC equals to 250,000 plus 11Q. If we plot it on the figure here, it's the blue line. So starts from 250, and the slope is 11 for A. We can do the same thing for B. We can draw a line of C and D. So location A is blue, B is green, C is black, and D is gray. We know that we want to find the lowest total annual cost. So the lowest we can see from this figure here. That is, in between this line and this line, we have the lowest line, that is the green line. In between this mark here on the quantity axis, which is the horizontal axis, and this point on the axis, the lowest line is the dark line, dark black line. And it goes beyond this point. The lowest is the blue line. So we know that in this part, if the quantity falls into this part, then green, which is B, has the lowest total cost. If the quantity is in between these two, then dark black, which is C location, has the lowest cost. Goes beyond this point, A is the location which will give the lowest cost. Our job is to find out this point, this point, and this point. So let's do one at a time. This point basically is 0, right? When the Q equals to 0. Okay, this is the easiest one. And this point is the cross of two lines. And the cross of two lines can tell us the mark on the horizontal axis. Where is the cross of those two lines? There are two lines here, which is, let's look at it carefully. Black line and a green line. So black is C, green is B. These two lines cross at this point, meaning that the total cost, these two lines of these two locations equal to each other at this point. And at this point is the line of the black and green. So C and A. When C and A cross, give this as this point. When this is B and C, C and A. Now let's first find out the point here where green line and black line cross. In order to calculate that, we'll write it down as this one, the total cost of C, which is the mark on the vertical axis, the total cost. The total cost of C equals to total cost of B. Total cost of C, the equation is 150,000 plus 20Q. Total cost for B is 100,000 plus 30Q. So we rearrange this equation here and we solve it. We get Q equals to 5,000. Okay, so we know that in between this and this point, the green line is the lowest, right? And we find that this point is 5,000 units. Then we know that in between 0 and 5,000 units, the green line, in other words, location B, gives us the lowest total cost. We do the similar thing to find out the cross of black line and the blue line here. Total cost of A equals to total cost of C. The equation for total cost of A is on the left hand. The equation for total cost of C is on the right hand. We solve it. We find Q equals to 11,111.11. We know that in between this point and this point, the black line is the lowest. And we know this point is a 5,000. And this point, we just solve it. It's right here. So we know that in between Q equals to 5,000 and Q equals to 11,111.11. B is the location with the lowest total cost. What about it goes beyond this point? We know that it's the blue line. So we know that above Q equals to 11,111.11, A is the location with the lowest cost.